Next, we have the HSV Color Model. Now, what does HSV, these three parameters, stand for? The H stands for hue, the S stands for saturation, and the V stands for value. Now, if we look at this diagram very carefully, the value basically shows us a vertical direction, as in from this bottom towards the top of this cylindrical shape. And if we look at the bottom of this cylindrical shape, if I keep going down, the colors keep getting darker and darker, and basically when I reach the bottom of this cylinder, I technically see no color present here, no matter what the saturation or hue value is. So I can pretty much indicate that the value basically controls the brightness of my colors here. And mind you that in this HSV color model, we get more parameters to work with, such as our saturation, which is this parameter, and this talks about the intensity of the color that we see on our screen. The brightness, of course, which is manipulated using this value parameter, and the hue itself, it basically selects which color we want to see. That is, the hue ranges from 0 to 360 degree. As we can see from an aerial view that the top part is basically a circle. And in this circle, every angle that I take, every angle is basically a different color. And for every different color, if I want to vary their intensity, that is from a pale red to a very bright red, that part is manipulated by this saturation parameter. As we can see, suppose if I take a color from here to here, I should be seeing a bright color, right? So if I vary the saturation from this point to here, from here to this point, if I start from the center and reach the circumference of the circle, the color at this angle that I want to see, its intensity basically increases, right? So my saturation helps me to control the intensity of the specific color that I want to see. The hue itself can set me the specific color that I want to see, and the value parameter, this basically controls the brightness of the color that I want to see. And since the hue values range from 0 to 360 degree, unlike the hue, the range of values that saturation can take is basically 0 to 1, and also the value can take values from 0 to 1. So if I want the color from at the bottom, the value here is equal to 0. And at the top, where the colors, all of the colors are the brightest, the value has the value of 1 here. And the saturation values at the circumferences of my circle here, as in the colors with their maximum intensity, the saturation value at these circumferences have the value 1, and right at the center, the value of saturation is equal to 0. So if I rub all these markings and show you that at the center, if I want to see the color yellow, we see that at the center, all of the colors become so pale that they merge into the color white. And of course, this color is at the top of my cylinder, right? So at this point, whatever the hue is, whatever angle the hue has, the saturation value should be 0 at this point if I want to see the color white, and the value should be having 1 here because this is at the top. This is if I want to see the color white. If I want to see the color black, if we look at the bottom colors, everywhere at this bottom circle, all of the colors, no matter the saturation or hue, we will be seeing the color black here. So all we need to do if we want to see the color black is set the value's value as 0, no matter what the saturation or value is. So again, why is this color model much advanced than the color models we have discussed before? Because it lets us manipulate intensity of specific colors and also their brightness. So using them, we can do shading, texturing, which you can see in this slide, which talks about HSV model applications. So here we can see that we can do a lot more with the HSV model, as in color selection in our illustrators, image processing, shading, lighting, special effects, even in image processing, gaming, and AI applications or digital visualizations. So we can easily understand that why the HSV color model is more powerful than the RGB or the CMY model. Now let's look at a bit more information about the HSV color model. It says that the hue, which is our color wheel, that is this specific wheel at the top, this one, for varying angles, we can definitely select different colors. And if we want to vary the color's intensity, that's when we manipulate saturation or values according to our demand. So the human eye can detect 4 hues, as in hues basically mean colors. So our human eye can basically distinguish between 400 colors. The other colors have so less or minimalist difference between them that our human eye basically sees them as the same color, but they're still different in the fundamental level. The saturation part, or the percentage or intensity of a color, it gives us 20 saturation level per hue. And what does it mean by this? Suppose I have an angle of 1 degree. Suppose I have an angle of 1 degree here, or suppose here, 20 saturation level basically means the color, the single color that I can see here, I can vary its intensity 20 times. Suppose here to here or here or here. From here, for 20 steps, I can go on. So basically, I can vary the intensity of this color 20 times. That's what it means from this line. As mentioned earlier, the value for saturation ranges between 0 to 1, and also for the value, it also actually ranges from 0 to 1. However, in some of our questions, you may see that at the end, they ask you to convert the value to a percentage. So that's when we multiply the value with 100 to represent it as a percentage. That is why it's written that it ranges from 0 to 100. But this is when we ask you to give the value as a percentage. Otherwise, the value ranges between 0 to 1. So let's discuss the model a bit more. This is another coordinate-like model for the HSV color model. So if we look closely here, the top part is basically a circle, right? So they have pretty much divided this circle into 3 segments. And why is that? Because of our 3 components, RGB. Right here, we start with red and assign it 0 degree. Since we have divided the 360 degree into 3 portions, if we divide 360 degree with 3, we get 120 degree. As in, the red's realm exists between 120 degree. The green realm, or the color green, exists within the next 120 degree. It can be till here or till here. Blue can also exist for 120 degree. As in, blue exists within this realm. If we move past this realm, there is almost no blue here. There is almost no blue here. Similarly, for red and green, it's the same case. So, if we look again, red begins from 0 degree and right after 120 degree, green dominates. And right after another 120 degree, that is at 240 degree, blue dominates. And if you see that this portion is basically equidistant from red and blue. And what color do we get if we have an equal mixture of blue and red? Magenta, of course. If we look at this angle value, it gives us the color yellow. And it has to be yellow because this angle is equidistant from red and green. And what color do we get if we have an equal mixture of red and green? Yellow, of course. Similarly, at this angle, we get the color cyan again. This is again equidistant from green and blue. And since it has an equal amount of green and blue, we get the color cyan here. So this is how the color wheel, if we look at top, if you see that this was our red, this was our green, and this was our blue part. And here we were getting magenta, here we were getting yellow, and here we were getting cyan. So this is represented here using angles. And again, where are the S and V parameters here? The S parameter basically is the saturation level. So from here to here, or from here to here, or from here to here, these give me my saturation values. And the value or the V itself starts from this point and goes all the way to this center point. So right at the bottom, V has a value of 0, as in it's all black. And at the center of this circle, V has the value 1 or maximum brightness. And at the center, we get the color white. So this is how the HSV color model works. Now, if we have cleared out what the HSV color model is, let's look at how we can convert an RGB value to HSV parameters. Let's begin. Initially, we will be given RGB values. If the RGB values are not scaled, as in not within the range 0 to 1, then we have to divide them by 255. After we have scaled them to 0 to 1, next, the first thing we will do is basically compute Cmax or Cmean. And what do I mean by that? Cmax is basically when we have RGB components here, the one which will have the maximum value will be my Cmax. And the one which will have the least amount there present will be my Cmean. And using these two, we will find the difference. So the differences formula is basically just Cmax minus Cmean. After I am done with part 2, that is I have my Cmax and Cmean present, I will go on to find my hue, basically my 3 parameters, hue, saturation, and value. How can we find hue here? Let's see. If my Cmax's value equal to 0, I will just blindly set the value of H equals to 0. If not, let's look at this line. If my Cmax equal to R, that is from the RGB components, the R has the maximum value, then H will basically be G value minus B value divided by the difference. This will be my H. If it's not the case, that is, if my Cmax is equal to the green component, then my H's formula will stand as 2 plus blue minus red divided by, again, the difference. And this plus 2 begins because if green is my dominant component, we pick Cmax based on who has the greatest value in RGB, right? So if green is my dominant color, if we look here at my color wheel at top, we see that green, the dominant color green, begins from the angle 120 degree. And if you look at this line, after calculating H's value from any of these three formulas, we at last multiply it with 60 to turn it into an angle. And we see that if green is my dominant color, we begin from 120 degree. So whenever we will multiply this with this formula, the 60 will be multiplied with 2 and will give me something plus 120 degree, right? Which means since green is dominant, it will begin from here. Similarly, blue begins from 240 degree, right? So if none of these cases are true, I will find my H using this formula, as in when blue will be my dominant color. So if blue is my dominant color, it should be beginning the angle calculation from 240 degree, right? So see, we add plus 4 here. So whenever we multiply H in the next step, 60 into 40 will give me 240 degree plus some other degree. So it will begin from the blue realm. And this is why this plus 2 and plus 4 are added here. So after calculating my hues or H's value from any of these four ones, mind you, we will not use them together. We will use any one of these four formulas based on what is my Cmax. After finding my H's value, I will multiply it with 60. And if after this calculation, my H value is something negative, then I have to complete this step as well, which is I have to add 360 degree with my H. If in this calculation H is not negative, then we do not need to use this step. So from here, my H parameter will be found out. Next, in order to find saturation here, we see that if my Cmax is 0, then I will just blindly put S is equal to 0, and then that would be my answer of S. But if not, then the formula to find S is simply the difference by Cmax. This will give me, and at last we see there is an into 100 here. This is if you're asked to provide your S as a percentage. This will give me my S value, and at the end, in order to find V, the formula of V is pretty direct. It's basically V is equal to my Cmax. This is how we can find out from RGB to HSV parameters. And here we have an example of it. We were given RGB value of 200, 150 and asked to find the HSV parameters. First, we normalize them by dividing the values with 255. Then, these are my new RGB component values. From here, we see that R has the greatest number, so my Cmax is red. We see that blue has the least value, so my C mean is blue and it's 0.196. In order to find the difference, we basically just subtract Cmax from C mean and we get 0.58. Now we will calculate the H, S, and V. In order to just calculate V, V is equal to Cmax, so this is our value of V. In order to find, since Cmax is not equal to 0, we will use this formula of S. So the difference divided by Cmax, this is my S value. And lastly, since Cmax is equal to R, this was my initial formula, and with that I multiply 60. The answer is a positive, so I do not need to add 360 with it. So my H's value is 20 degree. So these three are the parameters of my HSV. Next, we will see how we can convert from HSV back to RGB values. How can we do this? Let's see. First, we find the chromatic component, or C. This basically tries to find out the dominant color among RGB. So the formula to find C is just simply V into S. V standing for the value and S standing for the saturation, which will be known. From here, we will find C. After finding out C, we have to find an intermediate value, X. And its formula is basically C into 1 minus the hue divided by 60, with which we will mod 2. Then we will subtract it from 1, take the modulus result and subtract it from 1 again, and then multiply it with the chromatic component, or C, which we have calculated from here. After this, we will find the adjustment M, which has a simple value of V minus C. This V again is our value which will be given, and this C is basically again this value which we found right at the beginning here. With this, with C, X, and M, the calculation will be half over. So next, what we will do is, looking at the value of H, if the given H is within 0 to 60 degree, R will be set as C, G will be set as X, and B will be set as 0. If it's between 60 degree to less than 120 degree, R will be set as X, G will be set as C, and B again as 0. If the angles fall between any of the other conditions, then you will set RGB as what's written here. So this would be the fourth step. After we have assigned the RGB here, the last step would be, remember how we calculated M here? The last step would be to adjust the RGB values by adding M to whatever we have calculated from here with all RGB components. And that would give me my final result. Let's look at an example of this. So my question will be given to me in a similar way like this, HSV, where H is 30 degree, saturation is 0.8, and value is 0.9, and I have been asked to find the RGB components. These are the values given. So in order to find C, I will multiply the value with saturation. This is my answer. From here, I have to find next X value. So this was the formula given. So I plug in all of these values. The H was given to me as 30 degree. So 30 divided by 60, I get 0.5. And 0.5 mod 2, modulus 2, will still give me 0.5. 0.5 minus 1 is basically negative 0.5. But I will take the modulus of this. So just 0.5. So 1 minus 0.5, I get 0.5 again. And with this, I will multiply the chromatic component, or C, to which my X's value would be 0.36. Next, I calculate the adjustment M. So the formula was simply V minus C. V is the value that I'm giving, and C is what I calculated here. So it's 0.9 minus 0.72. This is my M. Now we have to go back to this table and see which condition to pick. The initial H value was giving 30 degree. So this actually falls in the first condition. So if this condition is true, R is set as C, G is set as X, and B is set as 0. So we go down and we set them whatever the condition tells us to. So R is C, G is X, and B is simply 0. After finding this out, I adjust the values by adding m to all of these three values. My m was 0.18, so 0.18 was added to all three of these values. So my final RGB components are this. Lastly, if they ask you to scale it back to 255, so you multiply all of these values with 255. And that is how we convert from HSV to RGB.